We're recording. Sweet. So this week in all things Python, we're going to move on to some complex objects, or more complex objects than what we've been dealing with. Lists, dictionaries, tuples, or tuples. I should say tuple because it's funny sounding. Each of them has its own object type in Python. So what does that mean? Well, I'm glad you asked. Well, you know how everything's an object? There's a type. Let's do a type of, let's do help on a list. 151 lines. So it's a class of an object. Well, it's an object, right? And the type is a list. It's iterable. So that means you could say for each item and then name your list. For each item in my list, do this, which is extremely helpful, especially if you have IPs, host names, usernames, account numbers, things like that. No arguments are given, creates an empty list. That's cool. All this fun stuff about the class, and that's about it. Well, how do you make a new one? Well, I could say my list ml equals list and hit enter. And then we type in ml, you get an empty class, right? You could also do, let's do mk equals, and we'll do open close parentheses and hit enter. And then we call an mk, we see that difference, so, right? ml, open close parentheses, and now we get our list. And I made mk into a tuple instead of a list. I forgot the square brackets. So let's fix that. mk equals open close square brackets. Now mk is a list as well. So we could check that by type. Get a list for both of them. They're both empty. So that's cool. That's how you create an empty list a couple ways. Call on list with open close parentheses and a variable, or you could just call on a variable with open close square brackets. Those will both give you empty lists. Now in this object, if you were to do dir on a list, it's like, okay, what can we do? We got insert, pop, remove, reverse, sort, count, extend. These are methods of that type of object. So we'll talk about pop. Reverse is handy, sort's handy, extend's cool, copy, clear, count. I use these pretty extensively. Extremely helpful. Lists are, let's see, probably one of the most common objects I work with is a list type, just because it's easy to iterate through and get stuff done. It's one of my favorites. But let's do this again. I'll just run this. We'll just dive into it. So right out the gate, a list is just a data structure that holds an ordered collection of items, ordered by index number, not by 1, 2, 3, 4, 5, like or A, B, C, D, E. You can sort it, but in reality, my shopping list, square bracket, object 0, 1, 2, 3. When I call on my shopping list, it prints my entire list. Apple is in index 0, mango is in 1, so on and so forth. So what else can we do? Well, here's how we make an empty list. One of the ways. Variable list equals list. Print my list. I get my empty list out. List with the range. So going way back to lesson 3 or 4, we call on range, give it a stop of 3. List, range, 3, print my range. I get 0, 1, and 2. Stop at 3. Helpful if you need a quick list of numbers. Other than that, I don't really use it that way. Got some more people coming in. Boop. And then Well, a list itself is an object, and it can hold different object types to include other lists. But here we created a list of integers by using the range command. And here we have, let's see what we got here. We're going to make a cheese list, cheddar, Edam, and Gouda. Right? Anybody ever I actually went out and bought this cheese because I'd never had it before. It's dead in between Swiss and Gouda. It's like a smoky cheddar almost. It's not bad. It's kind of light. But everything we learned last class with indexes, it works. So you can call on cheeses index 1. This is 0, this is 1. And we get our cheese that we call on. Pretty cool. So this is a list of all strings. Well, next we create a list. First item's a string, float, integer, then another list. And we print that list, and that's fine, more than acceptable. A list is just an object type that could hold an ordered collection of items. It's pretty simple. It's so simple it catches some people up, you know. And here we have a list of lists. First list, electric 50. Next list, gas 60, cell 60. And now we call it on index and subindex. We say my bills 1, 0. So if this is 0, this is 1, this is 1, and then we call on 0. So we should get gas back, and we sure do. That's pretty handy if you get weird list to list back. There's another object, a dictionary, that is a key value pair. That's a little bit more powerful than a list of lists with like objects like this. This is basically saying the key of electric has the value of 50. That's what a dictionary is designed to do. But you could use a list if needed. Back to cheeses. We got our cheeses, we got our numbers, we got an empty list. We say print, cheeses, numbers, empty, and that's what we do. We just print out the list, but we get the brackets around them. Not that fun, not that exciting, right? So what does mutable mean? Anybody read the book or catch what mutable is, or since we started?
Able to change.
Got it. That's it. Alteration, changeable, editable, however you want to say it. Some definitions are better than others, but able to change is perfect. Lists are mutable. A tuple is not. And I'll get to that on reasoning why in a couple minutes. So here we create a list called numbers, 17 and 123. This is pretty cool. So we say numbers index 1 equals 5. Then we print out numbers. That's a pretty darn quick way to replace an item in a list, is call out the indice you want and then give it an equals with a new value. It's like replace. It does replace the item. It's insanely efficient. Pretty cool. Let's take out some of the functions here in the list. So a list, being an object, has methods, and these are actually functions that apply to the object type. So here we have a list of integers. Print them out. Here we go. Good to go, right here. Length, it'll count how many items are in the list. In this case, we have 6. Insanely handy. Your boss hands you a list or a text file of who knows how many host addresses. Well, you can grab that. You could, from lesson 7, we'll learn how to ingest that, create a list out of that, and just do length and go, man, you want me to ping 10,400 machines? And they'll go, oh, I didn't know that list was that big, right? And really quickly with one command, once you have it in a data set or a list, You could use length to find out how many objects you have to perform what duties on. Super awesome. Max for numbers does just that. It'll grab the maximum number integer. Min, yep, you guessed it. I have to say I don't use those too often. Sum, I do use quite often when I have a bunch of integers. Extremely handy. And you'll see that you could do the same for a string entity or a mixed list. Here, cheeses, we have 3, length, 3. Max is Gouda. What? And min is cheddar. Python does it by the first Unicode value of the first character of the string. It doesn't add them all up. So keep that in mind. That's how it does min and max there. It's necessarily not alphabetical, as you've proven right there, right? Max and min, you may think opposite, but it's more of a value of the Unicode representation. And you get that by using order char, right? So here, what's the ordinal of capital G? What's the ordinal of capital C? So you see that, how does this come out? Min, max, min, max, where am I here? Yeah, so max is Gouda at 71 and cheddar comes at 67. Sum does not work on strings. It'll break. That's why I commented that out, but it will toss you an error. Like if you go over here and call on cheeses and try to sum cheeses, it'll be like, hey, unsupported operand for types integer and string. Okay, cool, right? That's why that's there. And what else we got here? We got a nested list with an object count. So let's take a look at this. So we have my list. It's a list. We have 1 object, 2 object, 3 object. That's a list. And 4 object. That's another list. And I say print the length of my list. Well, it only gives me 4. It doesn't count the sub lists. You can. Got some people. Admit all. So we have some, when we look at this, we have objects of objects inside a list, which is fine, right? Now, here we go traversing a list. This is, remember, they're iterable out of the gate. So you could use your for loop and just say, for piece in cheeses, print piece, and it goes, your list is cheddar, Adam, Gouda, cheddar, Adam, Gouda. Pretty awesome, right? For loops are insanely handy with lists, especially when you get into system administration. And I'm going to keep beating this up. Usernames, IPs, looking for updates, patches, file hashes, anything. If you have a list of them, you can iterate through stuff pretty quickly to find them. But that's your entry to lists. What do you think so far? They're not scary, are they? I don't think they're scary. Let's keep going. Any questions so far? They kind of feel familiar, right? They kind of feel like more with strings because they have the whole index property going on, the min-max length, or the min-max lengths. They all kind of feel the same, which is good. But they are pretty complex objects. Yay! Let me kill this, start a new one. Boop, boop, boop. So this is going to be cool, right? So here, cheeses, got our list. We're going to stick with cheeses. For each item in my range length of cheeses, print cheeses item times 2. Pretty cool? Not cool? Length of cheeses starts at 0, ends at 2. So the length of cheeses is going to be 3. So the range of 3 is 0 through 2. You don't have to do this. You could just dump cheeses right there, it'll be fine. This is just a representation of coupling everything we've learned so far, which is totally fine. So now you're saying for each item in my range starting at 0, 0, print cheeses 0 times 2. There's your cheddar. Then 1 into C1 times 2 into C3 times 2. That's it. Cool stuff. Now we're going to slide into operators. We used these in our first lesson a long time ago, and they still work with lists. So here we have two different lists. A, B, C is A plus B, print C, and we get A, 1, 2, 3, and 4, 5, 6 alpha together in one list. If the two lists, if you add two lists together, that's what you get. If you flipped it and did B plus A, it would read 4, 5, 6, A, 1, 2, 3. It didn't sort them. We just built them sorted and added them together. Some other quick things. 0. Well, this is print the list of 0 times 4. So it actually multiplies what's in there times 4, and then we get 4 zeros, 4 items. Same thing with this. So this is a list with 1, 2, 3 times 3. It does not do 3 times 1, 3 times 2, 3 times 3. It says 3 times the list. 1, 2, 3, and that's what we get. Quick way to duplicate things if you needed to. Cheeses, here we go again. And we print out our cheddar list right here, and our best friend in. Gouda in cheeses, you got it, true. Your Boolean operators that we learned about strings still work in lists. This is crazily helpful. Like I said, going back to that list of host names, 10,000 host names in a CSV or a text file, you read them into a list. You don't have to scroll. You don't have to hit Control F and find it. Read them in through a list and say simply what you're looking for in the list name. It'll come back true or false. That's a fast way to find a needle in a haystack. Do you agree?
For sure.
Super quick. In is so overlooked. It's like the secret grep of Python. It's pretty awesome. And here we go, slicing. So everything we learned about slicing strings, you guessed it, it works with lists. So here we have a list of strings, A through F. We say print my list, starting at 1, stopping at 3. Starting at 1, stopping at 3, BC. There we go. From the beginning to 4, boop, got that. From 3 to the end, yep, 3 to the end. 0, 1, 2, 3 to the end. That's what we got. And then this is print my list, print the whole list from beginning to end. And that's right there. That's right there. So you see how a lot of these methods that we used on strings and a lot of these operators that we used early off in lesson 1 with simple objects work with lists? It's pretty cool. It really does save a lot of time when you start to master stuff and you know what type of objects you have. So let's check this out. This is another quick way to replace things. Here's my list, A through F. I say call on my list, slice it from 1 stopping at 3, and that equals 1 through 3 will equal X and Y. So in the output, it replaces B and C with X and Y directly. Super handy, right? Any questions on what we covered so far before we dive into more methods? Because this right here is like slicing, using in, operators, or addition and multiplication, and our for loop. Next up is methods. Functions of a class, methods. And this class object, you guessed it, class object is list. Anybody have anything? Cool, let's keep going. So here we create a quick list, T square bracket ABC, call it our list dot append, and we give it a D string, and we say print it. You guessed it. D goes to the end. Append, apply to the end. It's that easy. Append is super awesome. Think of this, how we iterated and like used counters. We added one to a counter. If you asked for the rock, paper, scissors, and you were not only collecting if they're right or wrong, but you were collecting their answers, you could say user answers empty list. First play, append empty list with rock. That's what user played. They guess rock again. Append with rock, append with rock, append with paper, append with scissors, append with rock, append with scissors, append with rock. Then you can count how many times they guessed rock, how many times they guessed scissors, how many times they guessed paper, not just how many times they won or lost. You can start to do some wild things with the data about what they guessed. Is that pretty cool? Yeah, super cool. It is. So here we go with extend. Extend is a lot like using the plus operator that we used up here. It's a bit more clean. What do I mean by that? Well, I think it's a bit more pleasing to the eye. And you're saying my list 1, extend it with list 2. Well, extend has end in it, and that's exactly what it does. It adds your second object or your object, your parameter to your first list. So it adds the A and E to the ABC to the end. Pretty cool. Sort, you guessed it. Python lists have a sort method, and it's usually quite helpful if all your objects in your list are the same type. So here we have a mixed up first 5 letters of the alphabet. We call on our list, we say sort it, and then we print it. Boop. You got it. A, B, C, D, E. Cool. It's awesome. Quick way to sort stuff, just call it the sort method. This is a little bit more tricky. Same thing. Jumbled up. We say sort reverse equals true. Let's go over that. My list, sort it, so it actually performs a sort, A, B, C, D, E, and then we say reverse equals true, which then goes, okay, A, B, C, D, E, you guessed it, E, D, C, B, A. It'll reverse it. A little different though, but this is extremely handy. Reverse equals true does come into play sometimes. And we got some more reverse. If you call on reverse without reverse equals true, this is the default. So that's what it performs. You notice it didn't sort them. A, B, E, C, D. We didn't fix that. It just reversed my list and it gave me my reverse list. You'll go through a couple challenges on these that'll clarify that. It'll make sense if you break it a couple times. You'll be like, oh man. But this is just reverse what I have, no problem. This is sort what I have, then reverse it. A little different. Okay, now we're going to start removing stuff. There's a bunch of different ways how to remove objects out of a list. Some are better than others. Some make more sense than others. Pop. Pop is pretty cool. So we have our list, A, B, C, D, E. Empty variable X. We call on our T, our list, and we pop into C2. And we print our list. You notice that C is gone in our main list. And when we print X, it's holding C. It doesn't remove it. It removes it. Let me phrase this. It doesn't remove it from Python's memory. It reallocates it to the variable space of X. So it pops it out of the list and stores it in a variable. Does that make sense? Water's amazing. Pop with no attributes will remove the last item. I love using that in a for loop. I love using pop with whatever item in a for loop, and then it removes whatever item. But you'll see, it's pretty cool. We'll go through a couple different scenarios with that. And let's see, show the difference in remove. So remove, you guessed it. Remove Tim. Tim should be an X. But when I go to print Tim, I get a none. Remove does that. It removes it from the list, but also from memory. So when you go to print X, none. Remove is a bit more violent than pop, right? But if you want to get rid of it for good, that works fine. Now, delete is a bit different. Delete's a function. Delete works best when you call on your list and then pass it an indice or a slice. So here we're saying my list 1, so it removes B. And if you want to delete the whole thing, delete T from 0 from the beginning to the end to 6. You guessed it, it'll delete the whole thing. Now when I try to delete an empty list and I say delete T, right? This is on line what? 95. When I delete T, it's gone. So when I go to try to print it here, I get this error message, the traceback telling me T's not found. Delete removes it from memory. Goodbye, delete, destroyed. What do you think? Lists are pretty cool. You starting to see like where they could have helped you out in other places up to now? Sorta. Not really. Because you
No,
solved
yeah, for
everything.
sure.
Yeah, oh yeah, they're helpful. But I mean, you knew how to solve the problems with what we learned up to that point, right? Every lesson. This is just adding more object types and more fun to the fire. This is it ends up becoming pretty powerful. There's so much. This is one of those lesson. It's like lesson 5, just tons and tons of information. This listen strings. Let's start a fresh one here. In the real world, I don't use a lot of lists with strings. I use a lot of, well, I can't say that. It's not true because I do break up logs into something like this pretty often. I use other objects in my list, like host names and user accounts, things like that, because those are objects as well, and they have other attributes underneath them. So these methods and everything you're learning how to manipulate lists, it's going to transfer from different languages and for different object types. It does help. Let's take a look at this, right? So list of strings, print it there. A string is a sequence of characters. We already know this from last lesson and the other lessons. It's a sequence of characters, has values. List of characters is not the same as a string. This is why last lesson some folks chose to use lists and it didn't work out as they thought. Yeah, because the name of the lesson was more fun with strings, not more fun with lists. Lists are a bit different. They have different characteristics. But you can convert a string to a list and go back and forth with that. And we'll have some fun. I don't know what this meant. I did that a long time ago. Let's go here, right? So S, spam. I simply call a list of S and print my new list. You guessed it. It took every character in my string, blew it up, called it its own object, put it in T. And that spam is now each character is an object of my or an item in my list. Sweet. Splitting, super helpful. Here's my string. I split my string on nothing, so it's going to default to a space. And I store it in T, and I print it out. You guessed it. I got every word in my sentence in a list. Could you have used this method in your last lab? Well, yeah, if you knew about it, right? Is it helpful? Sort of. I think it's easier to master strings and understand the indices and those methods on how to do your Caesar cipher and then use it a list. It just makes it sloppy. It's two different things too. Like when you're manipulating a string, you want to manipulate a string. When you're manipulating an object or a list in an object or an object in a list, you want a list. And there's two different methodologies. There's a rule of thumb that if you don't know how to manipulate an object, just turn it to a string and manipulate it how you need as a string. It's always helpful, right? So then same thing works with this. Now that we took our string, split it on a space, stored it in T, now we can call on the indices and get what we need here. We said T2, which is 0, 1, and 2, and we got the. Awesome. Delimiters are important. Until you start working with data, you won't really understand how important they are. They are important. Spam dash, spam dash, spam. Split on dash. You guessed it. It removes the dash, and now you have just what you were desired, right? This works very well with comma separated value CSV files. Everything's separated with the comma. You split it on a comma, you get everything in every cell in its own object in a list. Very helpful. Join's pretty cool. Check this out. So now we're going to take strings in a list. Delimiter is a space. And I'm going to say my delimiter, which is just a variable name, which is space, dot join my list. And here it rebuilds our sentence for us. It joined the three items together with the space, creating our Tiny for the Fjords, right? All Monty Python references. So here we have print, aliasing and referencing. So this is important. Let me do this. Yeah, okay, that's fine. So alias and referencing. The association of a variable with an object is called a reference. Association of a variable with an object is a reference. So A equals 1, 2, 3. B equals A. B is A. True. You just said B equals A, and A holds an object or a list. Is it a copy? You'll see that A, 1, 2, 3, B equals A. If B equals A and it comes back true, if I call on B, indices 0, which is 1, and say you're now 17, and I print both my lists, you'll see that it changed them both. It's a reference. So in other words, B references A. It's not a duplicate object. It may have a different memory location because B does, but B points at A and says, what's in you is now part of me. And A's like, cool, well, it's always mine. But B also has the power to change it, and it will impact A. Just be careful with that. right? Now we get into immutable objects. What's going on here? So A equals banana. Boop. B equals A. Is A is B. True. Okay. So it acts the same. And now I create a new reference for B, and I say B is apple. Okay, I redefined what's in B in memory. So I got my banana, got my apple, and when I say A is B, I get a false. That's just to, this is like aliasing, but it's not the best, right? When do you want to copy an object or reference an object? Like, you could actually copy a list. We'll get to that. But there is a difference between referencing, aliasing, and copying. Fun stuff, right? Isn't this fun?
Yeah, I have a question actually.
Hit me.
So this this is crazy. So we're messing with tuples now. Now that you have a parentheses around it, it's a tuple, correct?
This is just printing.
Oh, okay.
Yeah, it's just the print parentheses and the parameter.
Okay, that makes more sense. I was like, you can't change a tuple, so I don't know how it's copying a tuple and then changing the tuple.
Tuples are, you can kind of you can change, alter some stuff, but let's see. I'll open the next one and we'll talk about it. I think it's tuple right now. Is it? Oh no, it talks about some functions and how to mess with some stuff. This is kind of fun. So bringing this all together, sort of like from all our lessons and lists and functions and all this cool stuff, you can build yourself a function that deletes the head or the leader of a list, and you can tell it by how much. So you can say define, delete the head, it takes a parameter, and then within your function, it deletes T0 or deletes whatever, right? So you can get kind of crazy with this. So you can say letters, ABC, delete head letters. Well, delete T0, T0, list 0 should be A, print letters. We'll just run it and see what's up. So right here, this print letters is this. The delete head takes a parameter, an argument. And after you call on delete head, it'll take whatever list object you have and delete the first item. Here we defined ABC, called on delete head and our letters, which is ABC, and we print letters, and guess what happened? It removed A. That's cool. That's cool if someone handed you a junky spreadsheet and every single item had an underscore or an exclamation point or a tilde in front of it. That's a fast way to delete them all, right? For each object in my list of objects, delete head, enter, boom, all gone. The whole front thing's gone. Pretty cool. And there are a few things that distinguish between operations that modify a list and that create a new list. The append method adds to an existing list, it modifies an existing list, but the plus operator creates the append or the plus operator, which is it's an operand, it actually creates a new list. So what really happens? One modifies an existing list, one creates a new list. That's it. It gets a little blurry the more you work with it. Your head will start to hurt. Get up, walk away, come back to it. Don't sit there and beat yourself up. And check this out. So T1 is 1 and 2. Cool. So my list T1 has 1 and 2 in it. I say T2 append with 3, print T1. Whoa, hold on. Why did it do that?
Because you modified it, not made a new one.
Exactly. So if I print T2, what do I get? None. I appended T1 with 3, which just adds 3 to this object. This variable's empty. Pretty bizarre. Bizarre, right? But that's how it works. Modification method is different from an operator. Now, if you say T3, you say T1 plus 4. So T1 is 1, 2, and 3. And I say T3 is T1 plus 4, print T3. It adds 4 to my 1, 2, 3. And if I say T2, which by the way is none, if I say T2 is T3, of course it's going to say false because this is T2, this is T3. They're not the same. You get a false. Pretty wild stuff. And then this is just the inverse of delete head, delete tail. You say from the beginning, go to the -1, which is the last item. So here I say tail letters, print the rest, and you'll see it removes C and gives me just A and B. Cool. Much like a remove function you could have wrote for lesson 5 to handle punctuation. Check if it's non-alphanumeric. If non-alphanumeric equals true, or if alphanumeric equals false, cut it or slice it from the end, store it in a variable called punctuation, deal with it later. Possibility. Fun stuff. Yeah, don't worry about doing that. It's when I teach in class and we used to have real books and stuff. Those are all gone. Real books are gone. They're all gone. But that's lists. Now it's tuple time. No, you guys want to do dictionaries? Dictionaries or tuples? It's up to you.
I
I
feel like
wrote dic
oh
oh,
yeah, go for it.
I was gonna say dictionary.
I was as well, so
Cool, let's do it. Dictionary is like a list, but more general. What does that mean? It doesn't have indices. That's what that means. The index position have to be integers. In a dictionary, the indices can be almost any type. So you're going to learn really quick. These are the predecessors to JSON, JavaScript object notation, key and a value. JSON, you could have a key with a value, or a key with multiple values. Don't worry, you could import JSON in Python and do a dir on JSON. You're going to see some commands called dump and dumps. It handles JSON just fine. JSON is nothing more than a complex dictionary, a key value pair. What do I mean by that? Well, before we dive into this, let's pull up one. I think W3C has some cool ones. JSON file example. Yeah, there we go. We'll just go to json.org. So check this out. Key value pair. Let me make it a little bigger. Boop. If I wanted to know the ISO abbreviation of this, I would call on glossary, title, glossary entry, ID, abbreviation, potentially. Or if you take a look how this is an item, it's nested in that bracket, and then you have these items nested in that bracket. You could jump brackets. You can go glossary, glossary division, glossary list, glossary entry, abbreviation. And then it'll poop this out back for you. This was the big difference between Web 1.0 and you guys remember that thing about 10 years ago, Web 2.0? Anybody?
Yeah.
This was it, mostly. It was just a changing between XML and JavaScript notation. Take a look at that. Let's go look at XML. Don't worry, Python has XML. Oh, 404 not found. What a shame. XML uses callouts or tags in front of each line. So this line would say abbreviation and then a slash abbreviation, less typing. JSON is double the less typing for field names. So it's less typing, more curly braces, a little bit of weird to look at. But once you start looking at these and you traverse a couple, or you start working with dictionaries, you got it. Here it is in it's right here in XML. So you see that it's like a same hierarchy. It's the glossary, gloss div, gloss this, entry, gloss term, and then oh, this is what I want. Let's make it a little smaller so. But you see how it's like it's the end of that definition right there with that / abbreviation. Pretty cool. So now you just learned something in class. You learn by reading a file type that's a JSON file, that's an XML file. You don't even have to look at the extension. You can see what's inside of it and go, yo, that looks like XML. Yo, it looks like JSON. Because JSON, you could do two things. You could say, hey, man, is ISO 8879 in here? True. It's in abbreviation. Or you could say, hey, is glossary abbreviation in here? Yes, it's ISO 8879. You get multiple ways to ask the same question. If you know one piece of information, you could find it. Pretty cool, right? A dictionary is nothing more than that, except simpler. Check this out. Here's how you build an empty one. Let's run this. So, English to Spanish dictionary. You call in the dict command, open close parentheses. You could also just do this without this. That'll create an empty dictionary as well. Either one. So here we create an empty dictionary, we print it, it's empty. This is how you add items to a dictionary. Key value pair. You call in your dictionary square bracket, you give it the key name, close your bracket, then it says equals uno. Then when you print out your dictionary, you get the key value pair. A key and a value is separated by a colon. So when you add your next key value pair of tu and dos, when you print it out, key value pair separated by a comma, key value pair. Now this becomes kind of fun. Calling on a key and value. When we call on our dictionary and we just throw it a square bracket with the word tu in it, it comes back. When you call on a key, guess what it does? It gives you the value. Helpful. Let's take a look at calling on keys with the in value. Key of 1 in my dictionary, true. Value of uno in my dictionary, false. In doesn't work with values. In only works with keys. But could I dump all the keys out into a list and use in? Yes, you can, right? Don't think you're ever going to be stopped in Python. It's engineered to be simple and quick, and for you to grab your data and throw it into a different type of object and find something that way if needed. So we're not going to talk about that. That's a pretty outside the scope of class, but we can get into those some other time. So here we go. Now, dictionaries have a method called values. So we call it our dictionary, we call it a method of values, throw it in a variable called vals. and we print vowels. Well, what do we get here? We get the dictionary values followed with parentheses and a list. If you want to change it to a list, you have to change it to a list. And then we just get the values as a list. You're going to skip this spot at one point in time. You're going to be mad. Focus on this. When you call in the values, it returns a dictionary object called dictionary values with your values in a list. To get them in a list, you have to toss them into a list and then call on them. Odd, I know, but it's helpful. Now, length still works. When you call length of my dictionary, it says 2. 2 key value pairs. 1, 2. 2. Awesome. Check this out. Min. Ooh, 1. Max. 2. Once again, ASCII value of a string, not in any specific order, not in a value, just the value of what they're worth. Before I move on, because I need you to focus, grab a sip of coffee, water. This is where we start to have fun with dictionaries. And I'm going to stress, don't deviate your variable names. So what does that mean? If you want to iterate through a dictionary, you can. I suggest calling on the value or key that you want and using the variable name key has a special place. For key in counts, well, here's my dictionary, has 3 items, key value pairs. For key in counts, print the key, so it should print parrot. And then I call on my dictionary name and that same key. It should print parrot, call in the dictionary, call in the key of parrot, which should give me the value. You want me to go over that one more time? Because I'm going to. For each key in my dictionary, print the key, counts, my dictionary name, then the key name, and it will give you the value. So for parrot is 1, for cheese is 42, for spam is 100. It'll print it out like that. That's what this does. Pretty cool. When do you think you'll receive a dictionary?
Any Excel file you get?
Potentially. A lot of times you could turn those into JSON, or you could read them in as comma separated values. But anytime when you have a key value pair, like if you wanted to do your translator again or Caesar cipher, could you put A:1, B:2, C:3? You could have done a dictionary Caesar ciphers and literally call on the key to get the value. You see what I'm saying? But it's really kind of the same thing of calling on the indice of an alphabet. There's tons of different ways to solve it, right? But this is kind of fun. Just I know there's a lot of counts, a lot of key, a lot of parrot talk. But once again, we have our fun-filled dictionary. Key list. Counts, keys. Key list, print my key list. You guessed it. We turn it to a list. This is how you get a list of your keys right here. Call the dictionary keys, dump it to a variable, change it to a list, rock and roll. Now, same thing. And now that you have a list of your keys, you can do whatever you want. You could sort them. And now that you sorted those, you could say for each key in my key list, print key counts key. So now you're using your list that's sorted, but now you're passing that key to your dictionary, and you're getting cheeses first, parrots second, spam last. It allows you different tools and different mentality and critical thinking skills using these tools to solve problems. Doesn't have a sort, right? Let's just keep adding to this because it's going to be fun. So now we're going to create a dictionary for every letter in Brontosaurus by using a bunch of stuff we've learned before. If, in will give you a true or false, not in will give you a true or false as well. Let's check this out. Dictionary. It's empty. It's an empty dictionary. We just use the command through it in dictionary. For each letter in my word, for B in my word, if letter not in dictionary, true because it's empty, dictionary letter equals 1. In other words, dictionary B has the value of 1. Cool. Now we dealt with B. R not in, true, 1. O not in, true, 1. N not in, true, 1. T not in, true, 1. O not in dictionary, false. Dictionary O equals dictionary O plus 1 to the value. So now O2 SAURRUS, and then what you get is you get a dictionary of the letters and the counts. You can do this to a word, a book, a page, an internet, a website, whatever you want. Now here comes the get method. Get method is my favorite method for dictionaries. One may say the most helpful if you have to do a lab. Get is awesome. It's not the get that goes out to the internet. It goes out and gets something from your dictionary. Now check this out. You have your dictionary. We've been calling on keys the whole time, right? Well, check this out. Counts, get, spam, comma, empty. Well, guess what it gets? It goes out to spam, calls on the value, it gets you 100. Cool. Get is touched upon in your book and your challenges a little bit. It'll become more relevant on how important that is when you go through those exercises. Get is an awesome method for a dictionary. Super cool stuff. And you can see how much it shortens our code logic. So here's our lines to count how many letters are in Brontosaurus. And I think we dropped off 2 lines by using get, because now we could say for each B in word, dictionary B equals dictionary.get B 0 plus 1. What? So we remove the entire if else check, right? So now this thing just goes dictionary get, well, B equals 0. B's not in there, plus 1. Cool. So BRO, let's go back to this O, right? There's already 1 in there. For O in my word, dictionary O. Well, that'll pull, and what you'll get is a dictionary 1, right? You'll get O plus O with the value of 1 already. And this says get letter. Oh, there already has a value of 1. We'll add 1 to that. So that's how you get your 2. Get is awesome. Super cool stuff. Basically, it's like saying key value, and the default value is 0. Unless you call in the key, it'll feed that value with whatever it has. Super handy. So that's a dictionary. What do you think? Any feels about dictionaries? They seem a little bit more complex with the key value talk. Just remember when you call in the key, you'll get the value, right? And there's a whole other section that we're going to cover next week during the group exercises that really hones in on how to work with the values and the keys. They are the gateway drug to understanding JSON, which is primarily almost everything on the internet today. A lot of databases also inhale JSON. Mongo, what's the other one? MongoDB and the one with the other Hadoop. They deal with JSON very well because they're objective-based databases, and they play well with different file types. But that's not too bad, right? It's a lot of stuff to take in. There are a lot of different object types this week, and there's a lot of different methods, but a majority of this stuff, slicing and the operands, the plus and multiplication, those work with strings. We've been doing it the whole time. So most of this is the new stuff is really how the methods work with these types of objects. Here comes tuple. So why do tuples even exist? It looks like a list. It feels like a list. Huh. Well, it looks like just by the sheer size of it, a list has more methods, more functions and methods than a tuple. That's by design. So tuples are objects that are immutable. You shouldn't be able to change them. Now, a lot of when you ask a question to some old school databases, they actually give you back a tuple. Why do you think a database on an external server gives you back a tuple?
For data to be clean. It doesn't want to be changed at all.
There you go. Tampering in transit, right? Doesn't want to be changed. So it's a safety mechanism, and it's very low rent. It's really not a safety mechanism at all, but there is a little bit of a chance that, hey, at least it's an object type you can't change, right? It's trying. It's very low level, but don't be confused between that and just the different types of object classes. You're going to see tuples a lot. They're surrounded just by the parentheses. A lot of data types come back as a tuple. You can have tuples in a list. You can have all kinds of fun stuff, as you can see. But the cool thing right here, tuple, you define a tuple, open, close parentheses, an object followed by a comma. What if I just did this? What if I did B equals, and what is that? Yeah, parenthesis. I do B. I do type. Did they fix this? I thought they fixed this in a new type of Python. Ooh, it's a string. So if I want this to be a tuple, I put a comma at the end of it, and now it's a tuple. This little comma right here destroys a lot of friendly relationships with people in tuples. A lot of people overlook it. They forget it. Just remember that, right? It's important. Immutable. All right, here we go. Print tuple function. Here we go. I take the word class, put the tuple function, give it the string class, print my T. It creates a tuple of every letter. Cool. Here we go with a tuple. We're just going to move right on to the next element. Tuple, call on 3. Cool. Feels a lot like a list, doesn't it? You can slice it, start at 1, end at 3. Okay, this feels a lot like a list. Ooh, assignment operators. Check this out. A, B, C, D, tuple, A, That's a brand new tuple with a capital A. And then I'm saying call on my current tuple starting at 1 going to the end. So it's starting at 1 going to the end, A plus that, print it. I have my tuple. I didn't change the tuple. I just said, give me the data from 1 to the end. And by the way, start with a capital A. I didn't change my tuple. I extrapolated the data from my tuple. There's a big difference, right? Certain things won't work. We'll see some of those. So we got some text. This is but a flesh wound. We're going to split it. We're going to print the words. So now we have a list. Tis but a flesh wound. I say T equals list. Okay, we're good here. Am I in the right spot? Tis but a flesh wound. Text split. Yep, okay. Now I say for list, for word and words, T append length word, print words, sort reverse true, blah, 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 print rest. And I print as I go. So let's take a look at this. What do I do first? But, for but in words. Append my list with the length of the but, which is 3, followed by the word, but. Print word. I get that line right there. You notice it creates a tuple within the list. Sort reverse, print T, nothing happens, it's all cool. Then I start going through each and every one, and you see the tuples grow inside the list. And then eventually I sort it, print reverse true. But tis a flesh wound, did I get wound flesh, but tis a. Cool, sort of cool. When have I ever had to do this? Never. But it allows you to understand that you could create a tuple from other data, a list, and store it in another list. Sort of cool. It is pretty cool, actually. Because sometimes you'll be handed data that looks like this, and you're like, son of a gun, what do I do? What could I do with this? Like, well, you can call the indice you want for each item in my list, but then you'll grab another list. So then you have to see if the type's a list or a tuple, and then change it, and then get the data from inside of it. It becomes a nested for loop as opposed to just give me the data, right? Which is kind of fun. Now here we go with assignments. Tuple assignment, M, this is a list. Have fun. Right? That's a list. X and Y equals M. Print M. Have fun. This is a copied list. It is not a reference, not an assignment. Right? Because it's the same, it's just, I'm just calling on M, getting my list out. Now when I call on X and Y, I have my X and Y from my list. If you have lists with only 2 things in it and you need them in like separate objects, this is the fastest way to do it. It says tuple assignment, but what it does is it really creates a 1-word tuple, but they got rid of that and it just gives you a string back. Like if you did a type on, I don't know if this is still in there, is that? Well, let's try. Let's call it X. Oh, it's still have, cool. See, it's a string, it's not a tuple. They've done some things with between Python 2.7 and Python 3.3 to now. So a lot of the things that used to be a pain in the ass because it was a tuple is no more. It just treats it like a string. So that's a reason we got to modify the book a little bit. So are you folks ready to see what is super awesome? And I use this literally at least twice a week. You guys ready? This is pretty important. Let me paint the picture for you. You got 2.6 billion emails a day. You're looking for a bad domain. You're looking for a bad username or bad domain, one of the two, right? So you get a list of all your tos or froms. Let's go froms. Monty@python.org. 2 variables, username, domain, address, split on the @. So the username is Monty and the domain is python.org. That is insanely helpful, especially when you're looking for just a bad domain. Or let's say bad username. If I said stevesmith@gmail.com is a valid email address, but I said stevesmith7 is invalid at gmail.com. They both have the same domain, but different username. Could you find all the domains and then parse them apart to find the username? Yeah, that's a real life thing. And this is because, people spoof emails and they change like one little letter or two little letters, but it gets pretty fun. So guess what a dictionary returns when you call out weird stuff? Well, this is where we're going to create a list. Got a dictionary, A10, C22, B1, key value pairs. We say items. Dictionary has a method called items, and then we dump it into a list. Well, guess what that gives you? It gives you a list of tuples. A10 is a tuple. C22 is a tuple. B1 is a tuple. But after you have it in that new form of a list of tuples, you can sort it, and then you can do A, B, C. That's how you sort a dictionary. You take the items, store it in a list, sort the list, and then you have your sorted dictionary items. That is important. You may need that later. So what we got here? This is kind of funny. So here, much like your, I think this is a lab you have to do coming up. States, Alabama, abbreviation, state name, abbreviation, state name. It's pretty handy, right? Random.choice, list states items. Okay, so it's going to randomly choose one of these key value pairs, a tuple, in a list. Cool. We do the same thing here. Store it in var1. We print var1. What do we get? How did it print Ohio? It didn't print Ohio. It's before that. We're back. It pulled Alaska. So this is kind of a cool way to randomize a player's decision or display an odd key value pair to them and have them guess it. What's the abbreviation of Alaska? AK. AK in my tuple, true. You got it right. See what I'm saying? We'll talk about this next week, though, when we beat up group labs. So let's have some more fun with these, right? So this right here is pretty awesome. This is for each key value. These are just variables. It could be anything you want to name them, but if you name them with the parts of the dictionary you want, it is very helpful. For each key value in the items, print value key. So it flipped them. 10A, 22, 1B, OH, Ohio. This is super helpful right here, being able to call out your individual keys and values. Fun stuff. What do you think? Not too confusing at all. We just covered like 10 billion things. Next week, we're going to put it to work. We're going to beat it up pretty good. Much like lesson 5, take your time, breathe, get comfortable with one type of object, go through lists, feel comfortable with it. Do the challenges for lists, then move on to tuples, then move on to dictionaries, or however you want to do it. They're all three very different. Dictionaries return tuples in a list form when you call on items. Dictionaries, when you call on dictionary items, it returns a list, square brackets, it returns a list full of tuples, round bracket, parentheses. Got some cool stuff. But yeah, that's about it for the brainwashing of this evening's Python methods and the mantra that is. I'm going to go ahead and stop the recording, then we can get into the meat and potatoes of the lesson.